All right, today we are doing our 5.5 notes, and in order to solve some of these problems that we want to talk about, we first need to review properties of quadrilaterals. So we talked about parallelograms last time, but let's refresh. So let's fill in this page together. So our parallelogram properties, our opposite sides are parallel, our opposite sides are congruent, our opposite angles are congruent, the diagonals bisect each other, and our consecutive angles are supplementary. So now we're going to be talking about some other quadrilaterals that are also parallelograms but have their own set of properties. So let's start with a rectangle. Because a rectangle is a parallelogram, all the parallelogram properties apply. To the rectangle. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and consecutive angles are supplementary. And in addition to that, all of our angles are right angles, and our diagonals are congruent. So that is the rectangle. Another type of parallelogram is a rhombus. And in a rhombus, so our properties of a rhombus are, again, all the properties of the parallelogram. Because it is a parallelogram. All the properties of a kite, which we will talk about in just a moment. All of the sides are congruent. The diagonals bisect the angles. The diagonals are perpendicular bisectors of each other. And the diagonals divide the rhombus into 4 congruent right triangles. So to demonstrate the congruent triangles, in my rhombus, I've got diagonals that are perpendicular bisectors of each other. So these are all right triangles, and they're all congruent by side, side, side. Okay. And then the last type of parallelogram that we're going to talk about is a square. And in a square, we have all the properties of a parallelogram, all the properties of a rectangle, all the properties of a rhombus. And in this case, when our diagonals divide into 4 right triangles, because our diagonals are congruent, it makes 4 isosceles right triangles. All right, now we're going to flip over to the back side and talk about some other types of quadrilaterals. Let's start with the kite, because remember our rhombus shares the properties of a kite. The first one is that two disjoint pairs of consecutive sides are congruent. And what this means is that the two disjoint sides, so they're consecutive sides and they're disjoint, our diagonals are perpendicular, one diagonal bisects a pair of opposite angles, and one pair of opposite angles are congruent. All right, and then another one we're going to talk about is the isosceles trapezoid. Now, an isosceles trapezoid has the same, properties as a trapezoid, and the properties of a trapezoid are just that the bases are parallel. So these top and bottom are parallel. So our bases are parallel. And then for an isosceles trapezoid, the legs are congruent. So our non-parallel sides are congruent. That's what makes it an isosceles trapezoid. And then properties of the isosceles trapezoid are that the lower base angles are congruent. So the two at the bottom. And our upper base angles are congruent to each other. The diagonals are congruent. And any lower base angle is supplementary to any upper base angle. So now that we've discussed our properties of our quadrilaterals, we can solve some practice problems. And so on your notes, that first page and part onto the second page, I have them written again, but you now have them also on your handout. So let's start with problem number 1 here. This is about a parallelogram. So AV is 2x minus 4. VR is 3y plus 5. RZ is 0.5x plus 8. And ZA is y plus 12. So we want to find the perimeter. Now, because this is a parallelogram, I know that one of my properties is that the opposite sides are congruent. So VA is congruent to RZ, and AZ is congruent to VR. So I'm going to have to solve for x and y before I can find the perimeter. So I'm going to set 2x that's minus 4 equal to 0.5x plus 8. So I get 1.5x is equal to 12, and I find that x is equal to 8. Then to solve for y, I'm going to set up 3y plus 5 equal to y plus 12. So 2y is equal to 7, so y is 3.5. But I'm not done. I need to find the perimeter. So I have to plug in my value of x into one of these sides. So 2 times 8 minus 4, that is equal to 16 minus 4, which is 12. So VA and RZ are both 12. Then I have to plug in my value of y, and I get 3 times 3.5 plus 5, and that's going to be equal to 15.5. So VR and AZ are both 15.5. So 12 plus 12 plus 15.5 plus 15.5 gives me a grand total of 55. And my perimeter of VRZA is 55. Okay. Now moving on to number 2, EJ is x plus 5, JG is 2x minus 1, and HF from here to here is 13. And I want to find EJ, JG, and HG. So because this is an isosceles trapezoid, I can refer to my properties, which we're slightly unfamiliar with. And remember, we're given information about our diagonals. And so we're told our diagonals are congruent. So that means that EG is congruent to HF. Now EG is equal to EJ plus JG. So x plus 5 plus 2x minus 1 is congruent to HF, which is 13. So I get that 3x plus 4 is equal to 13. 3x is equal to 9, and therefore x is equal to 3. So EJ is equal to 3 plus 5, which is 8. JG is equal to 2 times 3 minus 1, which is 5. Now, finding HJ is a little bit trickier, and we have to use some of our knowledge about congruent triangles in order to determine the length of HJ. So first of all, another property of our isosceles trapezoid is that our legs are congruent and that our base angles are congruent. So if I'm taking a look at triangle HEF and triangle GFE, I know that I've got congruent triangles here at the bottom because of side angle side, side angle side. Where EF is a shared side, it's congruent to itself by a reflexive property. So if that's the case, then this angle EHJ would be congruent to FGJ because of CPCTC. Another thing I can conclude is that these two angles here are congruent because they are vertical angles, which means that these two smaller triangles, JHE and JGF, are congruent by angle, angle, side. Angle, angle, side. So because those are congruent triangles, HJ is congruent to GJ by CPCTC. And GJ or JG is 5, which means that HJ is also 5. So we didn't have to write that out as a proof, but that is the thought process we had to work through in order to solve for HJ. Okay. Moving on to problem 3, I have a kite, and we know it's a kite because we have the consecutive pairs of disjoint sides. And I'm told that angle IPT is equal to 5x minus 10, and that KP is 6x. And we want to find KT. So, in order to do that, what I need to do first is solve for x. Now, I know that in a kite, my diagonals are perpendicular. So I know that this angle here is a right angle, and so it's 90 degrees. So 5x minus 10 is equal to 90 degrees. So I can solve for x, and I get that x is 20. So now I know that KP is 6x, but I don't know what PT is. So remember that one of the other properties of my kite is that one of the diagonals bisects, bisects a pair of opposite angles. And so that means that it bisects these two angles here. So triangle KIP is congruent to TIP by angle, angle, side, because this is also a right angle. So that means that KP and PT are congruent by CPCTC, so this is also 6x. So KT is equal to 12x. And because x is 20, I just need to find 12 times 20, which is 240. All right. Got a couple more problems. Moving on to number 4.